I'm asking you to stop your problems. If you haven't finished 1 through 7, would you please do that this evening or when I finish this little blurb? And take out this paper. You can show it to them. You can show them yours.
Oh,
Mine's too
I was
far.
like-
Show them Brandon's, one of the two there. Okay. All right. The idea that we're going to finish with is power. And we have a couple, what was it, how many more, 2 or 3 more to do in the back of this sheet, which have to do with this idea. So the whole idea goes like this. Suppose that I cut the lawn, it's a push mower. So I'm cutting the lawn and it takes me an hour to do it. Then the next week, same height of grass, same lawn, you cut the lawn and you do it in half an hour. Who has done the most work? Who has pushed that? Remember, work is force times distance. Say we're using the same force on the machine, and the distance was the same lawn. So you've done the same amount of work as I have, but you did it a whole lot quicker. So how do we distinguish between the two sets? We do that with a concept called power. So you had more power than I did, because power is going to be the work divided by time. So if you would take that note there on this new sheet, that is key to power is work divided by time. So work, let's keep thinking about that. Work is an amount of energy. And so we're going to expect that to be in joules. Work is in joules. When we look at it as an energy, it's also in joules. And time, we're going to do time in seconds, as we often do. So you got that written down? All right, so we need power is work divided by time, or another way of thinking it is the amount of energy divided by time. These are the same idea. So we need a unit. On the top, power, the unit for power, we're going to have joules on the top, seconds on the bottom, as I already indicated. Joules per second is how we read that, and we decided to rename it. What did we rename it to be?
A watt.
A watt. How did you know? All right, so this is a watt. And it's named after James Watt, who did a lot in physics. He did steam power and obviously understood this concept. So we don't have to have, we really don't have to use watts. We could use any unit that is, remember a joule is a Newton meter over time. So we could use any one. You know how your curriculum loves to ask at least one question on every test about units? So I think it does that with the watt. So let's just make up another one. It won't be a watt, but it will be a legitimate power unit. So what's another way of saying newtons? What do we say in America? When you get on the scale, what does it say? So we have pounds, and then we need a unit for length. Say foot, remember foot pounds, pound feet. Foot pounds over time, seconds, or we'll change it to minutes. So a foot pound per minute is also a legitimate unit for power. So be able to give me some and recognize some that are legitimate. All right, and so we'll do one problem, and I think you'll be set to work with power. So the problem is draw a rock. I am a rock, and I'm pushing the rock, and when I do that push, it's going to, when I push the rock, it's going to have, we're going to have 54 newtons is the weight of the rock. 54 newtons is the weight of the rock. It's going to go 4.3 meters. And I'm going to do that. It's going to take, it's a long time. That's what it says, 2.1 minutes. All right, So it's going to take you a long time to move that rock 4.3 meters, so which is just across the room basically. So 2.1 minutes must be 54 newtons, must be pretty heavy. So all I want you to do is find the power that is exerted during this episode. So can you take the idea right here that power is work divided by time? Remember, work is force. Here's our force. Force is in newtons. Work is force times distance. And time in this one, we're going to change it to seconds so we can use watts. So we're going to use this formula. I'll make a space in the middle there. Alright, what's left is all you need. The problem and the basic formula. Power is work divided by time. So, finding the power, I'm going to say power is work. Work is force force parallel and back in torque land divided by time. Force parallel is, the force is 54 newtons, the distance is 4.3, and the time is, what's 2.1 in seconds?
126.
Thank you. So,
Convert it to seconds.
alright, so when you divide all that, multiply and divide, what is the wattage? Anyone get 1.8?
Yeah.
Alright, 1.8 watts if you follow that through. So that's really all I have to say about power. There's not much to say. It's, instead of just figuring out work, it's work divided by time and you're done. You got the power. If you use newtons and seconds, you're in watts. Alright, for the remaining, what, minute? August?
We have like 8 minutes.
That's right, we go to 25 of. Let's do the power problems on the back, and we'll finish up the friction problems, what I call friction problems. Work and kinetic energy friction problems. Work on the back. Now you're ready to finish it with your understanding of power. Recall that we are reviewing on Monday and testing on Tuesday. We're done this chapter. All right, so have they saw this worksheet. I think they saw the front of it. Could you show, before we turn it off, could you show them the back of it?
The whole back, or?
Yeah. We're ready to do the whole back now. Why don't you show them the front so they have the answers to work toward?
Okay.
Yours are correct. Am I correct?
Yeah.
Okay. They've been checked. All right, for some reason you're not able to finish all this, please complete it tonight. So on your day, whatever we were on, 5, 4, 5, 5, 6, whatever day, the homework is to complete this sheet.
Okay, can I turn it off now?
All right, that's it for us.
Bye.
Bye.